Example 7. Prove that yz to the power of log y by z, zx to the power of log z by x, and xy to the power of log x by y is equals to 1. So, yz, I would assume the left hand side is equals to some k value. So, yz to the power of log y by z and zx to the power of log z by x and xy to the power of log x by y, and that is equals to k. And taking logarithms on both sides, we know when ABC, we know logarithm of ABC can be written as log A plus log B plus log C. By using that way, if you take logarithms on both sides, logarithm of yz to the power of log y by z and zx to the power of log z by x and xy to the power of log x by y is equals to log k. And simplifying that, log a b c can be written as log a plus log b plus log c. Therefore, log a means log yz to the power of log y by z, k, plus log zx to the power of log z by x plus logarithm of xy to the power of log x by y is equals to log k. And on left hand side, this can be written as log a power m can be written as m log a log y by z into log yz plus log z by x into log zx. This exponent comes as a multiple. Okay. Therefore, plus log x by y times log xy is equals to log k. But log a by b is nothing but log a minus log b. So, log y minus log z multiply by log y plus log z plus log z minus log x multiply by log z plus log x plus log x minus log y multiply by log x plus log y is equals to log k. And this is a plus b into a minus b, a square minus b square. So, log y whole square minus log z whole square plus a minus b, a plus b, log z whole square minus log x whole square plus and this is log x whole square minus log y whole square is equals to log k. Now, you see that every term on left hand side get cancelled. That implies log k is equals to 0. Log k 0 means definitely the k value has to be is equals to 1. Therefore, the expression is equals to 1.